Hi everyone, my name is Linda Lee and my teammate presenting with me today is Norman Mach. We will be discussing our research titled Which Restaurant to Choose, Mining the Topics and Sentiment of Yelp Restaurant Reviews. Our agenda for today, first is the overview of our research, second is LDA, then we will talk about sentiment analysis, then we will go into results, contributions, and future studies and limitations. With over 184 million reviews, Yelp is a titan in the review industry. However, the motivation of our research comes from the lack of specificity and sophistication from Yelp's current filtering system. And what I mean by that is if we were to go on Yelp and filter reviews, we would see that we would be only able to search and select from this current rating system, which for some consumers is not so helpful. The data that we used is from Yelp's Dataset Challenge Round 13, where we extracted and analyzed restaurant reviews through LDA and sentiment analysis. The goal of our research is to build a better recommendation system for Yelp to increase helpfulness of reviews for consumers. The table that you see here are the results of the data cleaning. You can see that we extracted 11,684 restaurants with over 638,023 reviews, and after splitting these reviews into sentences, we had over 5 million sentences. Further cleaning resulted in filtering English-only reviews and pairing one review to one restaurant. And for our performance evaluation, we used 9,653 sentences. This is an overview of our research model, which was broken up into 4 phases. Phase 1 was data cleaning. Phase 2, topic extraction through a program called RapidMiner. Phase 3, sentiment analysis through Python. And Phase 4, performance evaluation. I will now hand it off to Norman to talk about LDA and sentiment analysis.
Latent direct allocation is a language-based machine learning that determines what topics are within a text and what words are associated within those topics. In this process, we'll reformat all our text to be lowercase and then we will tokenize them. We then strip all the words down to their Latin root origin. There are words that we don't want in our process to pick up, so we have a word dictionary full of spell words for our process to exclude. The LDA then runs the algorithm to categorize our input text by topic and then distinguish what words are associated to each topic. Sentiment analysis is the process of determining if a text is positive, negative, or neutral comment. After we run our input through the LDA process, we run it through our sentiment analysis code. We created a code that runs each word of every sentence through 3-word dictionaries to determine whether those words are positive, negative, or negation words. Negation words switch positive sentiment into negative sentiment, and vice versa. The code determines the sentiment of the text depending on the total number of positive or negative values in the text. And with that, we have a machine process that determines the topic and sentiment value of text.
To evaluate our performance accuracy, we used a method of intercoder reliability, which is where 2 or more human coders manually code the same set, and we check for agreement accuracy. We used an online tool called Recal2. The table on this slide shows the results, and you can see that we have nearly perfect accuracy. To evaluate our model performance of both our LDA model and sentiment analysis, we took the machine output and compared it to human code. Our baseline accuracy for topics was 20% per topic, and we did reach that baseline. You can see that majority of the sentences were about food and service, and that can indicate that overall customers care most about food and service and are more inclined to talk about that in their reviews. Here is the table for sentiment accuracy. The baseline per sentiment is 33%, and we were able to meet that baseline. You can see that we had significantly more positive sentences than negative or neutral, and that can mean that customers typically feel more inclined to write a review when they had a good experience at a restaurant. So our research contribution, this study is an extension of previous studies of automating topic extraction to develop a filter recommendation system. This study is needed because the large volume of reviews can cause customers and business owners to make ineffective decisions. The practical contributions of this research is designing an online review system like Yelp, and the study can be extended to building a dashboard for business owners to track what their customers like and dislike. Finally, limitations and future studies. A limitation that we incurred was the processing power of our computers. It limited the amount of data that we can process, which is why from our initial 5 million review sentences, we had to cut down to a little over 100,000 sentences. Another limitation that we had was we were limited to 1 topic classification per sentence. For future studies, we hope to utilize cloud computing so that we have more processing power, meaning that we can process more data. We hope to optimize model by updating the dictionary. We hope to create a better NLP model that parses sentences by context rather than punctuation. We hope to use other classification algorithms to classify each sentence into one or more topics, and we hope to expand this study to other areas of tourism and hospitality. So that pretty much wraps up our research. Thank you so much for taking the time to listen, and we hoped you enjoyed learning about topic extraction and sentiment analysis. Thank you.